Welcome back. In this video, we're going to try to find the equation of the tangent line to the circle. X squared plus y squared is equal to 13 at the point minus 2, 3. Here, this point belongs to the circle. Why? Because we have minus 2 squared plus 3 squared is 13. And therefore, we are trying to find, so it is the circle in general, and it is centered at the origin here, because we have a equals b equals 0. And the radius here is the square root of 13. This point belongs to the circle. Okay, so it's here. And we want to find the tangent, the equation of the tangent to the circle at this point, minus 2, 3. Okay? The key idea here is that we will use the dot product or the scalar product to find this line. Okay? Note here that this is the center. We're going to call it omega. And this is our point A. And this is M that has coordinate x, y that belongs to the line that will be tangent to the circle. We see that here, this angle here is 90 degrees. Therefore, we can say that AM dotted with A omega is 0. Okay? Because we know that according to the definition of the dot product, this one is the modulus, or the norm of AM times the norm of A omega times the cosine of the angle AM A omega. And this angle is pi over 2 or 90 degrees, and the cosine of this one here is 0. The cosine of pi over 2 is 0. Therefore, we have 0. Okay? So we're going to use this one here, and we're going to use analytical geometry to write this one in the dot product form. Okay? So we have AM is, so the coordinate of M are x and y. So we have x minus a, that means plus 2, and y minus 3. Let me change this color here. So we have x plus 2, y minus 3, and we have a omega. The coordinate of omega are 0, 0, and those of a are 2 and 3. Therefore, we have 2 minus 3. And we know that in this case, the dot product AM A omega is x plus 2, y minus 3, dotted with 2 minus 3 is 0. According to this definition here, because the angle is 90 degrees. Okay, so here we do the dot product in the following manner. So we multiply component-wise, so the x coordinates of the first vector times the x coordinate of the second vector, and we add the y coordinate of the second vector times the y coordinate of the second vector as well. So we have 2 times x plus 2 minus 3 times y minus 3 is 0. Therefore, we get 2x plus 4 minus 3y plus 9, which is 0. And this gives me 2x minus 3y plus 13 is 0. And this is the equation that I'm looking for. If I graph nicely this equation, x squared plus y squared is 13. So here the center is 0, 0, and the radius is the square root of 13. Okay, I can graph it nicely here. The square root of 13 is 3 point something. 1, 2, 3. I can do it this way. And when I graph, so this is minus 2, 3. When I graph this line here, it will completely be tangent to the circle. Okay? So this is the equation here at this point A that has coordinates -2, 3. A quick way to check before we write down the solution or the equation of the line is that this point A belongs to the circle. We check that. We need also to check that it belongs to the line, because this is the common point that belongs to both the line and the circle. Here we check that it does belong to our line that's tangent to the circle at this point. Here we have 2 times -2 minus 3 times 3 plus 13. Is it going to give us 0? So we have -4 minus 9 plus 13, which is 0. Therefore, -2, 3 completely belong to our line that we're going to call it D. Okay? That means this is my equation. That's the equation of the line that's tangent to the circle at this point -2, 3. This is the quickest way of finding the line. Okay? There are other ways that we can do to find the line. We can, for instance, we can compute the slope here at this point. Okay? And the slope at this point should match this upper half of the circle. Okay? But here we are not going to use derivatives to find this result. We use just algebra and pre-calculus to find the equation, and that's what we did here. If you see any errors or mistakes, please let me know. Thank you very much.